Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, well, welcome everyone. Today we are so excited to have with us Martin Odersky, who I got to work with long ago at TypeSafe on Scala stuff. And Martin, I'm sure many of you all know him, but he is the creator of Scala and has been doing some amazing research with the Scala language at EPFL in Lausanne, a beautiful city on Lake Geneva, right, in Switzerland?
Yep.
Yeah. Well, welcome, Martin. Good to have you.
Great to be here. Thanks, James and Bruce.
Yeah. So, as you know, Bruce and I have been working on a book with Scala 3 and have just been loving a lot of the Scala 3 stuff that you have done. And so I wanted to start by asking you, what are some of your favorite features in Scala 3?
Well, if I say indentation, then we can fill the rest of the podcast with that. But
No, I think we all agree that it's a
it
desirable
really is my
feature.
favorite feature because it really affects every line of code I write. And every line of code I write, I just say, it's so liberating not to have to write these curly braces anymore and things like that. So
Yeah.
I mean, day-to-day indentation, I guess.
I also love the indentation. It just looks so nice when I write code now.
I've been using Python since the mid-90s, so obviously I like it.
Obviously, yeah.
So one question on that is, what's happening with the fewer braces syntax? Because on some of my Scala 3 code bases, I turned on the fewer braces syntax and I love it. Like it's like just even better, you know.
Can you explain that? I'm not sure what you're talking
so
about.
there's a experimental language feature called like fewer braces or something, and Martin can tell us more about it. But it makes it so that you don't have to use braces like anywhere, and it is amazing. The only place that I think I use them now is in imports to do when you do multiple imports.
That's the only way. Yeah. So fewer braces basically means if you have like a control structure like a flat map with a long closure or a logged or something like that, then right now, if the argument is like a block with local definitions and you have to put it in braces, and now you just can finish the line with a colon and indent, and then the whole thing will become the function argument. Or you can do the same thing with, like if it's a map, then you can write xs.map, and then no braces, but just x arrow, and then new line, indent, and then the rest of the block. So basically, you don't need the braces anymore, almost anywhere except for imports, maybe. Yeah. So I want to get this in as quickly as possible. We're getting some pushback from the tool vendors, so IntelliJ and Visual Studio, who say, well, wait, not so fast. We have to update our editors before, because otherwise the tooling experience will suck. And so I'm now currently pushing them to essentially prioritize that they can get it in for Scala Meta and for IntelliJ. And
I guess that's one of the hard things creating a programming language, is that you're not just creating it for me as a developer. Like you've got a lot of different people who a change to a programming language is going to impact in a lot of different ways, and you have to kind of balance all those.
Well, and it's like the Python 2 to 3 experience. For me, it was just like, cool, this is all good stuff, but then it took forever to get the libraries to convert.
Yeah, there's the library ecosystem is one of the groups that you have to balance needs with.
Yeah. And so there we have the one advantage is that we even from 3 we can still run with 2.13, so there's less need. So you don't need to bifurcate the libraries, or at least not for the moment. You can still run with the old ones.
Right.
And maybe that would be an interesting place to go next. Is how did you do that? Was Tasty really the foundation for being able to do that, or what were the pieces that made it so that you could use 2.13 libraries in Scala 3? And I've done it, and it's amazing that it works. But I'm curious about how that actually came together.
No, it's actually not. It has nothing to do with Tasty. It's because 213 doesn't compile to tasty. So we just
Okay.
basically unpickle the 213 as it is and translate that. So that's it. Sort of was, we had it from the start, because when you bootstrap a thing, you need to run with some libraries. So we said, well, we need to be able to work with the 213 libraries, or at the time when we started, it was 212 rather. And so we had to have from the start a reader for the 212, 213 symbol information. And then it was sort of, since the languages are not quite the same in some points, so we had to sort of deal with that, sort of make map things and things like that. It's a lot of small things to make that work. But yeah, I mean, since the fact that it does work is a big help to a lot of people now.
Yeah.
So, were you ever okay? I think probably the most impressive thing to me about Scala is the I don't know, boldness of experimentation. But were you ever like tempted to say, why don't we just leave Scala as it is and create a whole new language so we don't have all this, baggage to
Yeah,
carry
Don't have to
around?
worry about 213 interop and yeah, all the
yeah, well, yeah. So in the early phases of the Dotty project, I was sitting on the fence for a long time to say, do we make a new language which just, well, interop is always good because it saves you time and work. You don't need to duplicate this stuff. So I wasn't wanting to compromise on interop, but to say backwards source compatibility, that was a question for a long time. So um, and it was, so in a sense, Scala 3 is really understood like Python 2 and Python 3, and not like, let's say, C sharp 2 and 3, where 3 is just the next number after 2. It really is a different language. And um, I the name choice was sort of to keep on sitting on the fence, to say we it is a new language and it is sort of an evolution of the old language. So I didn't really want to sort of jump one way or the other completely. But before the final Scala 3, there were certain things where we wanted to be more radical, and in the end we weren't, because we decided, actually it was mostly the enthusiasm of the Scala community that started porting this stuff, and we said, well, actually this can really fly. I mean, people are picking this up, people are enthusiastic, and therefore we don't really want to make life sort of needlessly complicated just to do something new. So then we became more conservative as we reached the final version, I think. So, for instance, one thing that we didn't have from the start was higher kind of types. We had something else, which was sort of name type parameters. So a sort of blend between type members and type parameters. I had a talk at Strange Loop a long time ago where I talked about that, about those ideas. And they turned out to be interesting, but we realized that a lot of libraries wouldn't port, and so in the end we buried these ideas and picked the same sort of rough overarching type structure as in Scala 2. Of course, with new types like union types and enums and things like that.
yeah. Yes, you're always having to balance, I think, as you want to move things forward, you have to also be thinking about where people are and how you're going to get them to where you want to
Yeah,
go. And I guess what you're saying with like higher kind of types is sometimes making some compromises on what would be the maybe ideal versus what would be um, more approachable or more adoptable by people. And that's got to
yeah,
that tension that you live in as a language designer has to be really challenging.
One thing
yeah, definitely, yeah, yeah.
I think, and again, I could have this wrong, but I feel like earlier, years before, you weren't that big of a fan of enums. And then I feel like you've become a pretty big fan of enums. Did I get that right?
Um, yeah, yeah. So I think so. So in terms of philosophy, I think Scala started as a fairly small language. I mean, it was sure expressive, but we were actually very conservative with adding features to the language. We wanted to have sort of the minimum possible that you could express things. And then enums were sort of not making the bar because we thought, well, there is a way to sort of encode them with this enumeration. We had this enumeration data type in Scala 2, which was library only. The compiler wasn't affected by that at all. And they could do a sort of enum, but people hated it in the end. So it was just too awkward. And so with Scala 3, it's also in retrospect, we had more than 10 years of heavy use of Scala, where we said, well, what are the pain points? What are people really finding difficult? And can we do something about that? So, and we're not going overboard with features, but we are sort of a bit more liberal to say, well, if there's a pain point that can be solved by the language, let's solve it by the language. So, and enums were one of these things where the pain point was, well, also the thing, Scala, I think, is still so that we don't want to really have single use features. We want to sort of have more transcending features. So enums got sort of sold to me when I figured out that we could do both algebraic data types and classical enums in one construct, and we could sort of be fluid from one to the other and say, well, if we do that, then I'm not claiming it's new. I think Swift does something very similar, but sort of that sort of brought it home to say, well, we have 2 pain points, the traditional enums. How do you set up a set of constants? And the other was if you wanted to emulate an algebraic data type in Scala, then you had to write a bunch of case classes, and it was rather heavyweight compared to like the alternatives in languages that had them natively. So we said, well, if you can essentially swat those two flies, then let's do that. Yeah, catch two birds with one stone.
I guess that's one of the things that I've appreciated about Scala is the attempt to find kind of the generalizations and then build the nice syntactic sugar things on top of those generalizations. And so, yeah, I think enums and ADTs are a great example of exactly that. Is like the enums are really nice in Scala 3. As we've been writing the book, we've used them in a number of places, and it just feels really nice. But then to have the underpinnings of ADTs, and when you want to use ADTs, that also feels really nice. But yeah, to have that based on a common generalization, I think, is a good approach that I appreciate.
Well, and
It
it
takes
seems,
time to discover that, right? Like to discover that you can do that. Discovering the generalizations can be really hard.
Oh, yeah.
so it seems like you use enums when you have like a fixed number of values, or that isn't huge, and then if you're beyond that, then you use a class that you define as an ADT.
Yeah, like what's a good example of when you would use a union ADT versus a enum?
Okay, a union versus an enum.
No, intersection. Sorry.
No,
right?
it's union.
Union.
Do it with a union.
Yeah.
Would you use a union? Well, I guess I don't usually use unions for that, because I have the impression that sort of the structural typing is sort of tends to have more verbose types and be worse for inference. So basically, when you say, well, a type has these 3 values, then I think it's better to write an enum and says, well, that's a type and those are the 3 values. Whereas a union type could be anything. You can union anything with anything else, and also it's more difficult to essentially then pattern match on it and things like that, I think.
Yeah.
So
we were also going to ask about Scala fix, the approach of trying to, well, I think partly to help move people from 2 to 3, but also if you have some features that you decided maybe weren't the best idea, to help move people away from them. Is that the right way of thinking about it?
Yeah, sure, yeah.
Well, in Scala 3, you actually removed a number of features from Scala 2, and it seems like helping people move away from those things through like Scala fix rules is really beneficial to the developer community. It's like you you want to be able to do these experiments, and sometimes you discover that the experiment was not correct or failed or whatever, and then you need people to be able to use a thing so that you can get feedback, so you can evaluate whether the experiment was successful or not. But then if it was unsuccessful, you got to be able to move people off of that thing.
Right,
And it
right,
seems like
yeah,
ScalaFix is part of that strategy for how you can be can do these experiments in the language, and then when they fail, move
you
people.
can rewrite. Yeah, 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 yeah. That's the point. Yeah,
It's an
that's what we
interesting
need it for.
it's a contrast with the way Java's been doing it, because they've
Yeah,
been introducing experimental features, and then sometimes they'll withdraw them before they put them in, which I don't know. Well, it'll be interesting to see how well that works,
yeah,
because it seems like committing to it enough for people to actually use it and find out whether it works or not is a different experience than saying,
yeah,
"Hey, we have this thing," and my inclination is, well, I'm not going to use it until it's really in the language.
yeah. But I think the thing we removed in two, I'm not sure they were meant as experiments. I think they were really what sort of we thought would be state of the art at the time, and it's just that we learned we have a lot more experience now about these things. That certain things are just have better ways to do it now. I think. Uh,
Yeah. Yeah, it's
in
like based on your understanding at the time, you did something one way, and then you later, maybe through that, learned that there was a better way to
Yeah,
approach that. Or
yeah.
and maybe can you give us an example of something you pulled out of Scala 2 in Scala 3, that got removed from Scala with Scala 3 to make it
Well,
more concrete?
some really simple things were like the compound types with the width, which have been replaced by the intersections, which reflects essentially a type that's better behaved than the previous one. So we thought that the syntax should change. And then there's of course the biggest, the elephant in the room is all the old macro system, which was essentially which got added uh, really quite unchecked, and uh, we we meant to control this thing. I still remember the meeting. I think it was Josh Zureth proposing it, to say, well, you have to put experimental on that thing. We're not ready to ship that yet. And we did. And then the next thing we found out is that the world at large completely ignored us and used these things anyway, and more heavily. And they stayed experimental until the last day of their life, but that didn't prevent anyone from using them. So now in Scala 3, actually, we take this much more seriously. We have experimental features, like fewer braces was one of them, and but there are essentially much more stricter usage conditions, which I think we got from Rust, that you can use an experimental feature only if your code is itself labeled experimental, so it must be transitive, or else you're running in a nightly or snapshot compiler, so not on a release compiler. So it means we really sort of limit the use of experimental much more than before. Probably more like, I don't know what Java's policy is, but I can imagine it's similar.
Yeah, and macros and metaprogramming are, I think, a really good illustration of exactly this thing. Is like, you macros were added in, and it clearly showed that there was a lot of power that people wanted to harness,
Yeah,
because so many people began building amazing, mind-blowing things with macros. But then you spent how many PhD years researching how to give people that power, but do it in a way that was, um, had other benefits. Was beneficial for the compiler, beneficial for type soundness, beneficial for tooling. So you wanted to, I don't know, like you spent a lot of time researching how to make that metaprogramming system better in
yeah.
Scala 3.
It was basically one PhD student's work, so 6 years, something like that, plus a postdoc, plus of course I was involved as well. And this one actually builds on like stuff done in other languages. So what we have is somewhat similar, not the same, but somewhat similar to what you would find in, let's say, Meta or Camel. And there are also sort of links to what people do in template Haskell and things like that. So there's sort of a tradition for doing these things, at least in functional languages.
Yeah.
And we followed that to some degree.
Would it ever make sense to start with the macro system and then build the language around that?
Good question. Yeah, because
Like start with meta programming and then get to
yeah,
programming.
that's basically the Lisp approach, right? Uh, and I haven't seen that work for types yet, for typed languages yet, which doesn't mean that he couldn't do it, but I haven't seen it yet. I mean, there's typed racket and things like that, but I don't know how far you can push it and how sort of pervasive it is. But so in retrospect, I mean, how Scala was created a long time ago. Before Scala, I did something super restricted, which was sort of a more pure calculus language built on something called joint calculus, which is itself a variant of pi calculus. So there was a lot of concurrency and things like that. And there was a super simple language built on that. And everything was done with encodings. So you essentially you didn't have classes, you had records only, and then you built things up from these things. And it turned out to be super annoying to program this thing because it's just these encodings, you had to repeat them all over again. So at the time we said, well, no, let's get rid of these encodings and just do some sort of solid practical abstractions like classes and pattern matching and things like that. And that was the origin of Scala at the time. But in retrospect, we could have said, well, if we had sort of jumped into metaprogramming and put metaprogramming on this sort of core language, what would we have gotten? I don't know it, but I guess it's a very interesting question to ask. Yeah.
Well, and I think that what we've seen in Scala 3 is that the metaprogramming model is that right balance, at least for Scala, is that right balance of giving the power that people want, but then also constraining it so that it doesn't do weird things or doesn't enable the craziness that you can have with macros. And so yeah, it's I think pretty amazing what you've arrived at for metaprogramming in Scala 3. It's yeah, and from a user standpoint, like I haven't written metaprogramming. I'm not that good of a programmer, but when I use it in libraries, it's just like, oh, this makes so much
Mm.
sense and works well, and yeah, works well with the tools. And
Yeah. So interestingly enough, the thing that one of the core things is something incredibly simple, you think, and that's just inlining. So essentially, inlining at typer level, and that's actually, if you get that right, then a lot of things follow, and it's surprisingly hard to get right. So that's why most people cop out and do sort of best effort inlining it in the back end, which in my mind doesn't help you anything, because if you can't rely on these things, then there's no use of them. Basically, they're just opportunistic optimizations. But
well, I think it took a lot of research to uncover what were the problems that people are actually solving with macros, and then how do you make those problems that they're trying to solve be something that is possible
yeah,
but constrained so that you're not having to write a macro.
yeah.
And inline is one of those examples where I think it took some time to kind of discover, like, oh, like one of the things that people are doing with macros is basically inlining, but that wasn't, I don't know, maybe that was immediately obvious or something for you, but
Inline was obvious, but afterwards, essentially, what kind of abstractions you support in the quotes and splices. So when you stage things, that took a lot of going back and forth with people from the community. So, for instance, we worked a lot with the protoquill people, with the quill people, because they were heavy macro users in 2, and they wanted to port to 3, and
yeah.
essentially there was some handholding with essentially Nicola, who is the PhD student, he told them that's how you do it. And there are other things where Nicola said, oh yeah, that's right, that doesn't work well yet. We have to change our ways a bit. So there was a lot of iterative development that way. And not
We
just
ha-
with Will, but also with other people.
we had Alexander on the podcast a while ago, so he was telling us about some of that. And yeah, it seemed like there was a really good collaboration between what he was trying to do and Nikolai, right? Nikolai was the
Yeah,
primary student
yeah,
on that. And going kind of back and forth to arrive to a solution that worked for both sides and maintained the thing that I think is one of the most amazing things of Scala 3 is the dot calculus that's underneath it. And it's one of the things that as we started writing Scala 3 code for the book, there was places where having that foundation of the dot calculus would reveal itself in like compile error messages that actually made so much sense and were so helpful. And I was like, oh my god, like this is like I'm sure just one of the many reasons why having a dot calculus is useful, but from the end user standpoint, I was like, oh, I'm so thankful that there is actual math underneath this thing.
Well, and also
yeah,
these error messages would come up, and you're going, how? How does it know that?
How does it know? Yeah.
ah,
Because they're just too insightful.
uh-huh.
Yeah.
Yeah. I
So,
guess. Yeah. Go ahead.
um, I would like to talk about error handling
Mhm.
because I know you've been thinking about that lately, and I have kind of been immersed in it for the last couple of months. In particular, like a question just came up the other day, which is like, well, one of the biggest system failures that happens is that when some kind of error is thrown and then it turns out that the error handling code has never been tested. So I'm wondering, would there be a way for us to? Is there some sort of scheme that we could use to allow verification that the error handling code has actually been tested? I mean, I know it's kind of a
Ooh.
second level thing,
Yeah,
but
like
it sure seems
how often do
useful.
people write tests to test their air handling?
Well,
That's
and
a
it's
good
the same
point.
as checked exceptions. You know, it's like, okay,
Yeah,
the idea of checked exceptions is the machine is going to help you make sure that you've covered all the error paths. And then it seems like, well, we need another level, which is to say the machine needs to help us verify that we've got tests for all of those.
yeah. And code coverage wouldn't do that. Should do that. No, a code
I don't know.
coverage
Would
to
it do it for error handling code, though?
principle, yes, but it probably would come up blank in most
Right.
cases.
I don't think it's been given a lot of thought.
Yeah,
Yeah.
yeah,
Yeah. And is there any compiler? Could you make the compiler do it instead of a code coverage tool of being like, hey, you're not handling this error case or something. I don't
You're
know.
not actually testing
Testing.
the
Yeah.
handler for the error
I mean, the
case.
Yeah.
compiler can test that there's a handler, that they can check that there's a handler, but it,
Yeah.
it can't really check that you have a test for that code. So
I mean,
how do
even
you
if you just put a decorator on it or something, and then it could do, you know, at some point, the machine could say, and if it's code coverage, I'm fine with that. It's just, I realize now that I think about the problem, I go, oh, and if that really is where so many of these failures are happening,
yeah,
Mhm.
yeah.
it's like,
Yeah, maybe give us some information on what your experiments have been around exceptions and error handling, because I know you've been thinking about that.
Yeah, so with the exceptions, I mean, one thing is, well, so essentially, what can you do with exceptions? You can abolish them, not use exceptions, or you can have checked exceptions, or you can have unchecked exceptions. And I guess many languages have unchecked exceptions, which have known problems, namely that exceptions should be part of your contract, and if you don't check, if you don't track them in the type system, then you're missing an essential piece, evidently. On the other hand, checked exceptions, as they are in Java, are incredibly painful. in particular for higher order functions, because they can't be effect polymorphic. So you should say, if I have a map, to say, well, a map, what exceptions does a map throw? Well, whatever the function it calls, those exceptions it throws. But it's hard to express this. It's actually possible in Java, but it's so cumbersome that people don't do that. They just have very sort of simplistic monomorphic exception systems that then are not flexible enough. Or you can sort of not use exceptions at all, but that's sort of not true, right? Is it? Because, I mean, who would want to put, let's say, a out of memory condition in your error type, or maybe also
Stack
a
Overflow is another example.
overflow, yeah,
Yeah.
or not a number, or well, not a number. You can survive, but other things, division by zero, or things like that, stupid things like that. Right? So
Yeah.
there are exceptions. There are always exceptions, and there will always be code that wants to handle some of these exceptions. Because even if you could say, well, it's just a panic, but I personally, when I get an exception in my code base, then I want to be able to catch that and see a stack trace, and maybe at least use that for diagnosis, and maybe even handling it. So I think that the question is just where do you draw the line in saying having like a sum type or something like that for errors, and where do you have exceptions? But you'll always have exceptions. And if you have exceptions, then at least you should be able to make them checkable, so to put them in the type system. And the work we have been doing is sort of work out ways to do that, which are actually a lot more general than just exceptions. So exceptions for us is essentially just sort of a showcase that everybody understands for this sort of work. So the idea is that instead of having an effect like an exception, you have a capability to have that effect. So instead of effects, we talk about capabilities. And capabilities are the classical object capabilities. That means they're typically parameters that you pass to your functions that give the function then the capability to do certain things. And in Scala, that's quite convenient because we have these implicit parameters, so we can pass these things automatically. And if you do that, then you solve the problem of effect polymorphism. So your map would be fine to say your map is actually a pure function. Your map doesn't throw anything, right? So, but your map calls a function that you pass it, the function to map, and that function that can either have an effect or not. And if it has an effect, then it will just keep a capability in the closure. That's why they're called closures. They close over things, right? So the closure that you pass to map closes over the capability, and therefore, whatever the function does, the whole expression will do. So it works out very, very nicely. So you get full effect polymorphism without changing a single little bit in the library. So things like that, they all essentially map over. But then there's one tricky bit, and that's to say we then want to be able to track. So some of these capabilities, I think most interesting capabilities, they have limited lifetime. Which means I call them then resources. So a resource is something that you cannot use as much as you want. There might be an end to it, like a file. After the file is closed, you can't use it anymore. Or you might not share it. So things that are accessible only from one thread and not others, for instance. So for capabilities, then, for instance, capability to throw an exception, let's be concrete again, that would be generated in the try expression. So the try would say, well, if I catch an exception, then of course the body of the try has the capability to throw that exception. And if I don't catch it, then no, because that would be an unhandled exception. So that's good. But then the problem is, well, how do I make sure that the body of the try doesn't smuggle out the capability in a closure or something like that, or an iterator that if I call it, then bomb, it throws the exception, but the try has gone away and the exception is unhandled. So we need to track these capabilities in the results of functions in types. And that's basically the type work that I've been working on that makes me quite exciting, because I think we can make some definite progress on that, and not just for effects and exceptions, but also, for instance, that would be a solution to this so-called what color is your function problem and many other problems out there. So it seems the same pattern comes again and again and again, that you say you need to have a handle what escapes sort of in the result of a computation.
Yeah.
So that sounds to me, I mean, in my limited understanding, that sounds to me like what we put inside of a monad. We go, oh, it's not just the result, but it's the result and the capabilities together.
Yes, yes.
Okay.
Good point. Yeah. So you can do that with monads, but it's typically a lot more local. So with the monad is sort of at every step, I have to do the monad composition. And if there are
Hmm.
several monads, it gets complicated. I have to use transformers. So that's why I want to have one of these Uber monads like Zero or something like that.
Hmm.
Um, but with capabilities, they scope. So a capability and an outer scope is available everywhere, and that makes it a lot more flexible. So I don't need. So basically, I can do this thing with same thing with monads, but I need to do a lot more plumbing than if I used capabilities. That's the main advantage of those.
And is this the same thing as algebraic effects? I've heard like some of the newer languages have been using the concept algebraic effects as I don't know. Is that the same thing
It's
as
not the same thing. It can be used for algebraic effects as well. So algebraic effects is basically one way. The most accessible way to look at it is they're all in a way or another resumable exceptions. So essentially they're a thing you can throw, you can go to a handler, and then the handler can decide to essentially go back to the original code that threw with some additional arguments to that code. So essentially when at the point where I throw, I can have to be prepared to essentially be resumed with some additional results. So that's essentially the classic pattern, and I can do that if I have continuations, and I can code up everything. So typically these algebraic effects, they sort of are sort of ways to dress up and structure programs that otherwise would just run with continuations. Continuations are sort of the low level unstructured way of dealing with these things. And the ability to have these things, like with exceptions, can also be wrapped in capabilities. So that's basically the thing. And that gives you, I believe, the same advantages as for the other effects, namely that you get polymorphism for free and these sort of things. Yeah.
So the when you're saying, okay, a function doesn't return enough information, so we're does that mean, are you returning a capability now, or is the capability a thing that's returned along with the result? How is
No,
that?
the capabilities. No. You pass it into the function. So if I write in Java a function f and it returns a string and it can throw IO exception. So IO exception is an effect. You can say.
Hmm.
And in the capability model, I would say I have a function. It takes a parameter which is a can throw IO exception. That's a capability. It takes that as a parameter, and it just returns a string.
And
But
that's now more general, because you're saying one of the things that capabilities can do is talk about exceptions, but they could talk about all kinds of. So you've generalized the concept of the function doing more than just returning a value.
yeah, and
Okay.
it's also not only effects, but a capability could also, for instance, be access to a piece of memory or things like that. So you could say, for instance, if you have like region allocation or something like that, a capability could model that as well.
Mhm.
Capabilities, or it could be some piece of security, access rights, or things like that.
It sounds
Capabilities are very, very
really
general. Yeah.
fundamental. It
Yeah,
sounds like
I mean, the
like a big
capabilities have been
shift.
with us for a long time now. So I mean, they sort of pop up time and time again in software for 40 years or something like that.
Uh-huh.
There have been operating systems based on capabilities. There's even hardware. There's a called Cherry. I don't know whether you've come across that. That's it's a thing from Microsoft. They have a new hardware where essentially every access to an object can be essentially hardware checked as a capability in the hardware. And that's sort of meant to be sort of a more hacker proof way to do that. It's sort of it's a new, fairly new development, but it might become interesting.
It
Huh.
also sounds like it might replace some of the things that you would do with a macro system. Not everything, but some of the things.
Macro system.
Well, in other words, you might have solved it with a macro system in the past, but now a capability would.
Yeah, probably. Yeah, yeah,
Hmm.
yeah. I think that
Hmm.
that's you can do a lot of things with macros. Yeah, yeah,
Hmm.
It's interesting how we one of the places where we have a lot of bugs in software typically is around resource management. That when you call something, you have no idea what resources are being used and if you're going to exhaust them, and if something goes wrong, if it needs to be closed, and just
right.
it seems like an endless source of bugs. And now we're saying that, hey, why don't we have the compiler check these things
Yeah,
so that we can be sure that things that are resources and need to be managed are going to be verified at the like by the call, like when you call it, but then that information is propagated up the chain,
yeah,
right? Is like the big piece that you've been working on with Scala, is like that propagation of that information through the whole chain of calls. Is that the right way to look at
yeah.
capabilities, or
Yes, in a sense, but we're sort of turning things around. So instead of pushing them up the calls in the result, we push them down the calls in the arguments. That's sort of this idea of flipping the thing to do capabilities. But yes, otherwise, yeah, exactly. So essentially, the whole question of resources and when can you use them and when are they no longer available, that is potentially a key to handle that. Yeah, yeah, and
yeah.
that makes it exciting, I think.
Yeah, I mean, it seems like we have the opportunity with this to knock out a whole class of bugs at compile time.
Exactly. Because I mean, if you look at it, like I mean, as you know, I really like functional programming, but in a sense, functional programming is also cheating. Functional programming is pretending there are no resources. So
Right.
essentially, everything is available. I have a garbage collector. I can do whatever, and then in the end, I might construct a program which then is a monad or something like that, and that's then the thing that I construct that actually does the heavy lifting and deals with those resources. But since it's in the monad, it's sort of away from the language. It's whatever
That's right.
rules the monad defines for these things.
Yeah.
And I have the impression that it could be quite beneficial if languages and type systems could reason about these things.
Yeah, and 100% on board with having the compiler do more to alleviate runtime issues. Like the like I are there people that are not on board with that idea? I guess like people get upset that compilers take too long and whatever, like there's a trade-off to that. But what takes a really long time is diagnosing runtime issues.
Yeah,
And
yeah,
so for me, I would much rather have the compiler give me a sense of safety so that I don't have to deal with runtime issues.
yeah. Well, there's a trade-off, no? Uh,
Yeah, I
the,
mean, the one of the biggest trade-offs is that traditionally the developer takes a productivity hit
exactly. Yeah,
with the hope that that runtime error is never going to happen. And I think that that's the hard thing, is designing the programming language such that the developer productivity hit is not significant.
yeah.
Well, and I
And
think
the
we're.
libraries, I should say, and the libraries,
Yeah.
because
Hmm.
essentially in any sort of decent programming language, you can do a lot with types. So then the question is, how much do you want to do, and how much do you essentially push into the API of your library, because that will increase the learning curve of your users if the types get too complicated. And I think a language has only a limited degree or to which they can influence that, because in the end it's the core libraries that will determine that. And
Yeah.
I do believe that Scala has quite a few Scala libraries from within TypeSafe and outside have gone overboard with that and have become were more complicated than they should have been. Just
Yeah.
to say that.
Yeah, I think another example of this is like value dependent types. Like I think it's a good idea that I can have a compiler throw a compile error based on the value of
Hmm.
something. You know, non-empty list is I think a canonical
Yeah,
example.
yeah,
Um, but I don't use, like in Scala, I don't really often use those libraries that give me that capability because it makes things really painful.
yeah,
And so
yeah,
so
exactly.
I'm just like, I'm just going to assume that my list is never empty, or whatever it may be, and imagine that I'm going to always be on the happy path, which could result in a runtime error.
Exactly.
um, but I think that the hope is that we figure out ways for the right path to be the easy path.
Yeah, yeah,
and
exactly.
and it takes a long time to kind of discover how to do that well. And
Very
yeah, I
much
think for
agree. Yeah,
generally value dependent types, we've not really figured out how to make value dependent types the easy path and the right path.
Yeah, because
exactly.
if a type is a set of values, then what value dependent types do, I think, is allow you to um, figure out information about the types based on their values rather than just saying, okay, you got to set up the rules uh, independently of that. I don't know. I've still been trying to figure out the.
There's an interesting example that we could dive into, which Scala kind of reveals is there are things you can do on collections in Scala that will fail if your list is empty. So what happens if you call sum on a list that is empty? What do you return there? And so Scala could say one way to deal with it would be that sum returns an option
Hmm.
of an int or whatever, and then every time you call sum, you have to deal with the fact that it's an option. And so that gets really painful. And so in my code, I most often will call sum, assuming that I'm never going to be on the unhappy path of being in an empty list, but definitely a possible source of bugs. And so the alternative would be to use a data structure that guarantees that your list is not empty.
Or a
And so if
fold,
you're in an what is that?
or a fold,
A fold, you can do a sum with a fold, but you
and
give
then
it that
give it an
initial
initial value.
value. That's
Yeah.
right. Yeah.
Actually,
Yeah. So
some
some
it's
could
a bad example. Some is a fault. I think some of an empty
it's
list is
implemented
zero.
as a fold,
But
but it
if you
probably
take,
has like a cert that says,
but let's say max would be a thing. So max or min, I don't think they would give you. I think they probably are defined only on non-empty or head or something like that. Head, of course, would not work for empty lists.
yeah, you're right. Some is a bad example because zero is,
Yeah,
that zero is the logical not, on a non-empty on a empty list. Zero is the result of some. But yeah, max and min would be a better
Mm.
example.
yeah, yeah. That's a good question. Yeah, you could have. I'm also I'm neither a fan of option because I think it's just kicking the can down the road. Somebody has to deal with these options,
Literally.
and I'm not a fan of non-empty list or type like that. All either typically, I mean, it's always
So
depends.
non-empty list, where things like non-empty list get annoying as a user, is that if you have a non-empty list type and then you call filter on it,
Yes.
you
Yeah,
no longer can be in non-empty
no,
list
yeah,
land. You have to then go into the case where my list after a filter could either be empty or non-empty,
exactly. Yeah,
and it just gets really painful
yeah,
to.
yeah.
So I think there's some tricky pieces there that modeling the real world is sometimes really hard, and so sometimes we just assume that we're on the happy path and never going to be off that. But
Well, modeling
Yeah.
always makes some assumptions. It's always based on an abstraction. So,
yeah,
Hmm.
yeah, and how far do you take all this? maybe depends on your use case. If I was writing code for a Mars rover, I'd probably want to be really sure about things. Whereas for other systems, it's like maybe it's going to blow up sometimes, and that's
And
okay.
you'd
Or
want
I
to
put a
make sure
test
that all
in.
your exception handling code was tested.
Yeah. Or I put a test in. Yeah, that's what I said. I mean, we always have tests as well. So it's not
But
Yeah.
you'd
always
want the
that we
machine
put.
to tell you that, yes, you've tested all of your exception handling code.
Yeah.
That's
Yeah. That would
for
be
the Mars
nice.
rover.
Yeah. Yeah. Yeah.
So you mentioned before we started recording some of the Rust-like stuff that you were working on in Scala. Is that the capabilities
Yeah,
stuff?
that's the capability stuff. And we're not there yet to do Rust, but sort of we can talk about resources, and Rust talks as well about resources in a way of speaking. So, in that sense, we're approaching it, and one could possibly do things that Rust also does, namely manual memory allocation and safe concurrency and these sort of things.
Yeah. Yeah, I think it's a super exciting area of development just because there's a whole class of bugs that hopefully will go away when our compilers will tell us that
Yeah,
we're um, not dealing with resources in a safe way.
yeah. And also, I think that, let's say, the Java thread system and concurrences memory model for threading is just, I believe in 10 years we will all believe that's completely insane, the way things were defined. I mean,
You mean the threads and
how
locks?
yeah, and that essentially every object, absolutely every object, can be accessed by every thread at any time unless you put in a synchronized and these sort of things. It seems terribly unsafe and unstructured to me, and sort of a constant source of bugs. So the way to deal with these things, to say, well, by default these things belong to a single thread, and if I want to make them shareable, then I have to declare that explicitly. Seems to be much better.
Well, I think that's why they ended up deprecating so many of the thread methods in
Yeah, but
Java.
that's still enough to stay to remain.
Oh yeah, you can
To
still
remain,
make a
yeah.
mess of it.
I mean, and don't get me wrong, it's a super solid and performant system. It's an amazing piece of engineering, but I think the user level access to it,
It's
I think, is in 10 years from now we'll say, well, this was just
way too easy to like
yeah, yeah.
foot gun
Foot gun,
ourselves.
way too much foot gun. Yeah, exactly.
Yeah.
I think of threads and locks as something that you only do in the small and that it doesn't scale.
Yeah,
That's yeah.
yeah.
It just gets unwieldy way too easily and way too quickly. Have you been following the Loom stuff? And do you like? Is there any way that Scala will be able to take advantage of that system?
Yeah, we did look at that. There was we had a workshop paper about when was that, half a year back. Uh, the workshop is called Hope, and that was about some work that a postdoc with me did on mapping essentially a monadic reflection uh, to to um, to use either Loom or one of these sort
Fiber
of
system, some other
Zio
fiber
or
system. Yeah.
Cats effect systems. Yeah, but you can essentially use Loom as an alternative backend for these for fibers, and so that's interesting because you can use Loom to sort of code up continuations in a way. It's not perfect. It has some memory leaks at the moment. And with that, you can code up algebraic effects or other things. I follow it with a lot of interest, and would be great to have it in a production JVM.
Yeah.
You
Yeah. And
used the phrase monadic reflection, I think, when you were explaining that.
Yeah, that's essentially. So if you look at async await, so that's just for essentially for futures. And then the question is, well, if we have code like that, and it can work with any monad. So essentially, you code up your monad, could be Zio or Cats effect. That's the two we demonstrated. or something else, and you can essentially still use async await out of the box with these things. So program in direct style, but essentially the underlying runtime semantics is a given monad. So that's what monadic reflection. That's what we meant with it. Yeah.
Huh. That's cool. It will be interesting to see as we get Loom and as we get capabilities, how the programming model evolves for people who are writing, non-blocking
Yeah.
stuff, but then also expressing the resource management piece of it.
Yeah,
Since
yeah. I think capabilities have a lot to offer there because I mentioned this what color is your function problem before.
yeah,
So essentially, that problem is that you say if you do it the way you do it with essentially explicit futures or suspend functions in Kotlin or things like that, then your world falls into essentially two hemispheres. One is async, the other is sync, and it's hard to essentially bridge the gaps, and it's very hard to have functions that work for both. And you can solve all this if you have a runtime like Loom, because then you can suspend anyway. Your runtime lets you do that, or let's say go routines in Go or things like that. If your runtime can do it, then that's fine. So the question is, does that answer all our questions, and also does it answer all our problems? And the answer is no, probably not, because in the end, suspending is an effect. So your program is different whether it can suspend or not. And if you just map everything to Loom or Go routines, then you hide that distinction. Then you don't have a distinction between async and sync anymore. So you don't want that either. There is a distinction. Async is an effect, but you want to be effect polymorphic. And then we come with capabilities, and with capabilities we can be effect polymorphic, and voila. So that's sort of the approach there.
huh. Bruce, as we've been trying to understand polymorphism outside of the bounds of inheritance, the polymorphic effects, that's got to be like another dimension to polymorphism that be fun
Well,
to
he said
explore.
effect polymorphism, not
Effect
polymorphic effect.
Yeah.
Yeah,
Well,
there you go.
it just means, look, it just means that something as simple as map, it throws an exception if the thing you pass it throws an exception. It blocks if the thing you pass it blocks. It just means that these sort of general things can be effectful or not, or have different effects depending on what you pass them. That's all it really is, and it's something that should be evident that it should work, but only it doesn't right now. It really
Right.
doesn't. So
Yeah,
Yeah, yeah.
that's exciting. Well, I love Scala 3, and you've done so much great work to make it just a really enjoyable programming language. And yeah, and then continue to innovate on some other fun and very useful things to make it's like, Bruce and I called this podcast the Happy Path Programming Podcast, because we really do like see that the future is this convergence of the happy path, the easy way and the right way. And Scala is definitely one of the places where I think that is really happening. So yeah, that's cool. Um, what else? What else is on your mind, Martin, as we wrap up? What else is exciting in Scala, or what are you thinking about in Scala 3 or beyond?
well, if you ask me about favorite features of Scala 3 beyond indentation, there's lots more, of course.
Yeah.
so, so
Type classes. I really like the first class
yeah,
type class support. And you posted on Twitter the example of doing what I was trying to do in Kotlin with a new experimental feature in Kotlin, and the type class Scala 3 type class support,
yeah, that's right.
which
Yeah,
was it's so clean and wonderful. And yeah, I really appreciate that feature of Scala 3. But yeah,
Oh,
what else for you? Yeah.
yeah.
actually,
So,
I have a question. Okay, I've been trying to kind of form how to describe type classes in my mind, and it's kind of like a default argument in a way.
Yeah, good point. We had a long when we discussed the design of type classes. We had a long discussion with Howie, who wanted to push for that to make them much more like default arguments. In the end, we didn't do it, but there's definitely a lot of overlap, and the different design could have pushed that further. So, in a sense, it's there is definitely overlap. Technically, the main difference from a user point of view is I get a default parameter. I still have to write open parents, close parents. I have to say, well, this function takes these arguments, and then some of them I leave out and I pass them by default. And of course, the default parameters, the default argument is given in the function definition. They define what it is. Whereas with type classes and general context parameters, I don't write the parents at all. So it just gets added as an additional, essentially, parameter block. And what it is depends on the context, where I am and what I enclose.
So it gathers it from the enclosing scope rather than
It gathers it
being
from the enclosing scope. That's the main difference. And we we sort of stumbled into that in Scala 2. It was sort of more like a discovery, because initially Scala 2 had something which I now want to get rid of, actually, and that's implicit conversions. So that actually came first in Scala 2, and that came because at the time there was a lot of people were worried about this problem of retroactive extension, that you say a class can implement only those interfaces that were given when you defined the class. And now, what if they're new interfaces? What do you do? How can you solve that? And I didn't find a good way. So I said, well, the best we can really do is sort of make it implement the interface by an implicit conversion. So that's how they ended up in Scala. And then we defined the rules for them. And in the end, we said, well, yes, but we can actually also have implicit parameters, and implicit parameters can do type classes. So I had a talk, actually, in 2006 or something like that, about poor man's type classes. That's what it was
Huh.
called. And those were these implicit parameters. I presented that to a bunch of Haskell folks at the time, and they didn't quite understand what I was up to, but never mind. So that's how they came about. And now with and I think they had some things that sort of were just the way historically the way they were developed and why they came out of implicit conversions. So in Scala 3 we now sort of put them in properly and essentially fixed a lot of the problems that we had before. And I think they work much better now, and they're much cleaner and hopefully less frightening than the old implicits were. So now the only thing we still have to do, and I think we're getting there bit by bit, is actually to get rid of implicit conversions. So that would be nice. Then we have only the good parts.
Well, and with the extension functions now,
Yeah,
I,
that's
I I feel like the developer experience is such that I don't need the implicit conversions anymore, because I just add the extension function and call it, and it's fine.
So could you say that type classes are a way to provide defaults that could be changed if you need to?
Uh, yes, you can say that. So one high level way to talk about it is to say, well, we know about type inference. The compiler will infer argument types to functions for us. What type classes are, they're really value inference. So we give the type that we want in the parameter, and we tell the compiler to synthesize a canonical instance for that type. There can be only one, or one more specific. Otherwise, there would be an ambiguity. So, for instance, the typical example is an ordering, where we say, well, we need an ordering for this type, and we have orderings for various types, and then we can make up new orderings, like a list ordering. I can make up, if I have an ordering of the elements, I can derive from that an ordering from the list, and so on. So the compiler will just synthesize these values, which are typically closures or objects that define these that implement these interfaces. That's what basically in the larger setting type classes are.
And
Yeah,
it
and
seems like
the
it
other
would.
use case that we've actually turned on in our book code is the equality. The is it called multiversal equality or
English
what's
multiversal equality, yeah.
yeah,
That's where you just need evidence that this type can be compared with that other type,
yep,
and sometimes
yeah,
these things are even compiled, like multiversal equality is compile time only. So in the end, you don't actually need a value. You just need sort of some evidence that the compiler gives you to say, okay, by the fact that I could construct this, it means that this type is comparable to this other type.
yeah.
So
It took me a while to get that because I guess some of it comes from Java. In Java, you can compare anything, but in Scala, you can with type classes turn on this thing that won't let something compile unless you
yeah,
have provided the evidence or the type class that two things can be compared.
yeah,
And but it took my brain a little while to understand. Oh, my type class is not actually doing the equals checking. It is just telling the compiler that these two things can be compared. And
that's one way to use them. Yeah, of course, there could be. I mean, the ordering type class does
right,
do the ordering checking. Yeah.
yeah,
But
yep,
I found that really useful for large scale refactorings, because that was sort of the single gap where you say, well, let's change all this bunch of elements from this type to that type, and usually you would say, well, type checker has my back, except for equality, it hadn't, right? So
that's
all
right.
your equality tests and contains tests and the derived thing just would silently fail, and that's why people. Well, I previously I was super scared to do some of these things, and now with that it's fearless refactoring. Really, I jump in and refactor the arbitrary
Right.
large parts of that without fear.
It also
Yep.
seems like type classes might solve the dependency injection thing that.
Yeah, yeah, of course, yeah, in a sense, because it means you can pass a context,
Mhm,
and that's dependency injection. So you rely on something that you get sort of implicitly. That's
mhm,
in our Scala 3 compiler. We rely on that basically everywhere. So essentially, everything that we do, almost every method that we have, actually gets a context. And the dependency injection compiler is very fine grained, because you start with a root context, and as you go down your program, you enrich it with a lot of information of what you have seen on the way, and that's sort of that drives a lot of things. So that in my perspective works actually really well. So
mm,
so
mm.
Hmm.
And the context, would that have to, like, can you add new operations as you go down, or does it have to fit the Liskov substitution principle?
yeah, it has to fit. So
Okay.
context has to, you have to have sort of a
Encompassing context.
encompassing context, which is
Okay.
actually uh, somewhere where we use mix-in compositions, which sometimes goes under the name cake pattern. Now for these contexts, I think Dick Wall, they called them parfait, but as like a small cake. uh,
Yeah.
because it means, because this context sort of, it gives you stuff from many different modules of the compiler. You want to sort of pass them everywhere, but each one just picks essentially some parts of the context that's interesting for them.
Hmm.
So you don't want to define it all together, because that way you wouldn't really have good encapsulation. So in the end, it turns out to be essentially a mix in a trait composition of several traits that essentially define different aspects of what this context is.
Okay.
Hmm.
Cool.
Well, that was awesome. Thank you for all you do with Scala, and it's yeah, I love it, and has been such an enjoyable thing for me to write code in, and so thank you, Martin, and
Thank you
thanks for
for
joining us on the podcast.
Yeah.
yeah, I had a lot of fun. Thank you.
Well, good. That's our goal.
Accomplished. Awesome. All right, thanks.